All right, so let's look at our first example of two small samples that are where the populations are normally distributed and the standard deviations, population standard deviations are the same. All right, so I've made a little table for you, but let's read through the information first. A software company markets a new computer game with two experimental packaging designs. Design 1 is sent to 11 stores. Their average sales the first month is 52 units with a sample standard deviation of 12 units. Design 2 is sent to 6 stores. Their average sales the first month is 46 units with sample standard deviation 10 units. Construct a point estimate and a 95% confidence interval for the difference in average monthly sales between the two package designs. Okay, so first, let's notice, since we want a 95% confidence interval, our alpha is 0.05, and then remember, for all confidence intervals, we want to divide that in 2, so we're looking at 0.025. Now, in a minute, we will look this up, but we need to get our degrees of freedom since we're going to have to find a t value here. So, our degrees of freedom are our n1 plus our n2 minus 2. So that's 11 plus 6 minus 2, and that is going to give us 15 degrees of freedom. I'll just say 15 df. All right, so let's go and put this into our calculator that's on StatTrek to see what our t of alpha over 2 is going to be. All right, so 0.025, 15 degrees of freedom. All right, so I'll put 15 in here and 0.025 into the probability, and let's move that up, hit calculate, and my t-score is 2.131. Now remember, with the confidence intervals, we don't care about its sign. Our plus and minus takes care of that. So 2.131. All right, so let's start filling into our formula for this confidence interval now. All right, so x bar 1 is 52. Our x bar 2 is 46. Plus and minus. Our t of alpha over 2 is 2.131. Square root, and just for the sake of typing faster, I'm going to put the words instead of looking up the symbol. And now we need the pooled variance. All right, so we haven't done that calculation yet. Let's go back up and do it. So our pooled variance, and again, instead of just trying to type out s sub p squared, I'm just writing pooled variance, is n1 minus 1. All right, well, that's 11 minus 1, so 10. And then s1 squared, 12 squared. And then we will have n2 minus 1. Well, that's 6 minus 1, so 5. And then s2 squared, so 10 squared. Now, of course, I could figure out those answers fairly quickly, but I'm just writing it out for you to see the steps here. And then divided by, there's my slash mark. There we go. Our n1 plus n2 minus 2 is really our degrees of freedom, notice. So I'm just going to go ahead and put 15 since we went ahead and did that calculation. All right, so really, I've got on the top 10 times 12 squared. Well, 12 squared is 144 times 10 is 140, or 1440 rather. And then 10 squared is 100 times 5, it gives me 500. And then finally, if we do that addition on top, that's 1940 divided by 15. And now I just need to finish that division. And that ends up being 129.33333. Lots of repeating threes. Now I am going to take that out about 6 decimal places for the sake of round off error. We want to be careful. So we've got the square root now. Let's finish our calculation of 129.33333 times 1 over, n1 is 11, plus 1 over n2 is 6, so, oops, over 6. All right, and now we need to do all of these calculations. All right, so I'm just going to do this a step at a time so you can make sure you're doing the right thing. 52 minus 46, we're just going to get 6. Still have our plus and our minus. All right, 2.13, I'm going to leave alone for the moment. And square root, I'm going to leave alone for the moment. And I'm going to do that calculation of 129.33333 times the 1 over 11 plus 1/6. All right. And that gives me 33.313131. All right. And now I'm ready to take the square root of that number. So I'm going to end up with, let me move the screen down just a little bit here, 6 plus and minus 2.131. And the square root of 33.31313, that ends up being 5.771753. And then I'm going to go ahead and do the multiplication of my 2.131 with my 5.771753. And I can round off to 2 decimal places, or actually I can round off to the whole number when we're finished with that. Now that multiplication ends up being 12.299605643. And since we started out with whole numbers, though, I'm going to go ahead and round this to the whole number. So we'll round it to just plain old 12. All right, so we'll have 6 minus 12. That's going to be negative 6. And 6 plus 12 is going to be 18. All right, so there's our confidence interval, but let's not forget to state our confidence statement. We are 95% confident the true difference between the two designs in average monthly sales is between negative 6 units and 12 units. Now later on, as we examine how confidence intervals can also help us with a hypothesis test, I want you to notice that 0 is in this confidence interval. 0 units is between negative 6 and 12. This tells us ahead of time, before we even do the hypothesis test, which we'll be doing in the next example, that since 0 is in there, that means no difference between the two designs. Could be a possibility. And when we do our hypothesis test, we'll find out that we are unable to reject the null hypothesis that there's no difference. And we can see that here by looking at the fact that 0 difference, 0 units, is actually in that confidence interval.